Hello, welcome to this lesson. In this video, you are going to solve this question I have on the screen. The question says, find the moment about point O. So let's look at how you are going to solve this question. Okay, so we know that moment, okay, is equal to force times the perpendicular distance, right? And then this perpendicular distance is the distance perpendicular to the line of action of the force, okay, from the point of what rotation. Okay, so in this case our point of rotation is point O, so you're going to have the moment to be force times what the perpendicular distance D, which is the distance, okay, from point O and then perpendicular to the line of action of what the force. So let's look at how you are going to solve this question. So from where I got the question from, this is the free body diagram that they drew for the figure, okay? And then you see that we have 40 degrees here, then we have another 40 degrees here. Okay, so let's look at how they got these angles, okay, and then we use it to solve this question. Okay, so you see this D here, which is the perpendicular distance, right? So when I actually look at this figure here, okay, let me use this figure and then use it to generate the angle so that we understand properly. Okay, so we have the figure here, okay, and then first of all we are going to look at how they generated the angles. So let me indicate the line of action of the force. Okay, so this is the line of action of the force, okay, and then we know that D will be perpendicular to this line, right? So let me draw my D. Okay, so let's take this to be our D. Okay, let's take it to be perpendicular to the line of action of the force. Okay, so you're going to have here to be 90 degrees. Okay, so this is our D. Okay, so let's look at how they got the angle. So we already know that this is 40 degrees, right? So what I'll do is that I will draw another line, okay, which will be parallel to the line of action of the force, and I'll draw it to pass through the point where the 2 meters was measured from. Okay, so let me try that. Okay, that's not perfect, so let me start from here. Okay, so let's take this to be the perpendicular distance. Okay, and then that is parallel to the line of action of the force. Okay, so since these two lines are parallel to each other, okay, L1 is parallel to the line of action of the force. Let's name it LA, line of action of the force. Okay, so L1 is parallel to the line of action of the force, so which means that uh, the angle here, which is 40 degrees, will be the same as the angle here, which is what 40 degrees. Okay, so what I'll do next is that I will draw another horizontal line here, okay, which will be perpendicular to the vertical pole. Okay, and then when I do this, you see that you are going to have alternating angles, which will make this angle here 40 degrees, right? And if the angle is 40 degrees, then you're going to have this angle here to be 50 degrees, right? And then if the angle is 50, the alternative, so you're going to have 50 degrees here, and then for that reason you're going to have 40 degrees here, right? So that's what gave us this figure that we have here. Okay, so from here let's look at how you are going to solve this question. Okay, so let me take away this figure that I drew. Okay, let me take out away this figure that I drew, and then let's go back to the question. Okay, so I had a free body diagram that the question gave here. All right, so now you know how come we have the 40 degrees there, right? Okay, so now let's look at what you are going to do. So what I'll do is that I'll divide D into two different parts, okay, which will be D1 and then D2. So this is D1 and then this is what D2. So in all, we are going to say that D is equal to D1 plus D2, right? So before you can find D, you must know what D1 is and then you must know what D2 is. So let's find both of them. So from this triangle that we have here, okay, let me indicate the corner point. Okay, so from this triangle that we have here, okay, you see that D1 is adjacent to the 40 degrees. So you can see that cosine of 40 degrees, okay, will be equal to D1 over 4 meters, right? So D1 will be equal to 4 cosine of 40 degrees, right? So that will be D1. And then for D2, okay, we know that this line here and then the line of action of the force are parallel to each other. So that means that the distance between them will be the same, right? So if I measure this distance here, okay, that should be the same as what? D2, right? So I can consider that distance also to be D2 because the two lines are parallel. So this will also be D2. Okay, so from here, okay, D2 is opposite, right? It's opposite to this 40 degrees here. So you're going to see that sine of 40 degrees should be equal to D2 over the 2 meters. So you're going to have D2 to be equal to 2 sine 40 degrees. Okay, so in all, you're going to have D to be equal to 4 cosine of 40 degrees plus 2 sine of 40 degrees. Okay, this will give us a value of 4.35 meters for D. So in all, you're going to get the moment about point O, okay, to be equal to the 600 Newton, okay, multiplying D, which is what? 4.35 meters. Okay, so let's simplify this and see what you're going to get. So 600 times 4.35 will give us a value of 2,610 Newton meter. So this will be the moment about point O. This is the first approach I have used. I'm going to use another approach to solve this question. So please make sure you like the video and then subscribe to the channel. Thank you very much for watching.